the seafloor of Panarea Island, Aeolian Archipelago. At 112 meters depth, there is one of the cultural treasures of the Mediterranean, the virtually intact wreck of a Roman cargo ship that sank almost 2,000 years ago. For archaeologists, a mine of information about ancient navigation, commerce, and life on board. But diving at this depth is still reserved for a limited number of divers, and studying the wreckage had so far proved nearly impossible. Nowadays, technology is coming to the aid of underwater archaeological research, with the arrival of a new generation of underwater robots that will enable the exploration of the seabed at an affordable cost. Robots like those developed by the European researchers of the ARROS project.
Ready to dive?
"20 meters depth, 12 altitude."
Does the sonar catches something?
Over the last 30 years, there have been significant investments in researching and developing autonomous underwater vehicles, AUVs for short. The oil industry has learned to use them to reduce the costs of surveys and the costs of monitoring of subsea pipelines. Military unmanned vehicles are used in dangerous activities, such as research and removal of underwater mines. Underwater robots have demonstrated their effectiveness in monitoring and controlling the seabed without endangering the lives of people at work on the operation.
If you look at the requirements of those industries and those applications, they're very similar to the requirements that archaeologists have, and the time is now right for some of those technologies to be transferred across to the archaeological application to enable archaeology to benefit from the reduced cost, the enhanced coverage, and perhaps also some security applications where there are archaeological sites that must be kept private.
Nowadays, it is possible to find these kind of technologies, vehicle, AUV, ROV, in the market, but it is better to have something that is devoted, finally, to have some vehicles, some equipment that are the best that we can have to manage this cultural heritage.
Thus, the creation of the ARROS project, funded by the European Commission under the 7th Framework Programme and coordinated by the University of Florence. ARROS stands for Archaeological Robot System for the World Seas, and its goal is the creation of autonomous underwater vehicles at low cost, able to cooperate with each other, and the development of techniques specifically designed for underwater archaeological research. One of the first challenges that ARROS project researchers had to tackle is the wide variety of situations where underwater robots can operate. These range from the search for archaeological sites in large tracts of sea to work within the restricted environments of wrecks. That's why the researchers decided to create different underwater robots specialized in handling specific tasks. The Typhoon is the largest underwater vehicle. The hull was designed and built during the Thesaurus project, an initiative financed by the region of Tuscany and completed in 2013 to safeguard important underwater archaeological sites. That program gave a fundamental scientific contribution to the birth of the ARROS project. Equipped with powerful engines, the long-range Typhoon AUV is capable of exploring the depths while carrying relatively heavy and cumbersome sensors on board. Marta is lighter and is built with a modular architecture. The vehicle can be reconfigured depending on the mission to perform.
The acronym MARTA stands for Marine Robotic Tool for Archaeology, and the idea is to have a tool that can be easily reconfigured on board the support vessel in order to address different tasks in the framework of the same archaeological campaign.
The U-Tracker is a vehicle smaller than the previous ones. Developed by the Italian company Edgelab, it can be deployed into the water from a small boat.
This A-size vehicle is a smart, small, cheap and open source platform which modify the way to approach the AUV technology, and to our opinion this also opened the possibility to all those groups which are interested in those kind of technology to have access to this platform without expensive budget.
The UCAT completes the fleet of the Arrows project. It is a biomimetic underwater vehicle developed by the Tallinn University of Technology with the support of Albatros Marine Technologies. And its propulsion system is composed of fins instead of propellers.
From the underwater archaeology point of view, it's a very important feature that fish are quiet swimmers, so they don't beat up the water. And in archaeology, when you go near to the bottom, and the bottom is always covered with some silt and mud or something, it's very difficult to use propelled vehicles, which is currently standard in underwater robotics. Because if you go close because you want to see well, and then you just beat up the mud from the bottom and you don't actually see anything.
To reduce the time spent at sea, the mini-submarines can move in a team and communicate with each other to exchange data, which are processed by the onboard computer. Since underwater radio links are impossible, acoustic modems working at lower frequencies are used to enable communication. The researchers from the Institute of Information Science and Technologies of the CNR Pisa work on data the vehicles bring back to the surface, including the integration of the acoustic images provided by sonars and optical images provided by cameras.
And the final result of this integration is a map where we have a bathymetry information provided by the acoustic sensors that has an added value given by the optical color information given by the mosaicing algorithm.
This is in particular an activity devoted to realize an immersive system where different kind of users can navigate on the seafloor as if they were using an interactive game.
This device is based on infrared sensors, and it can detect the position of the hands and the position of the fingers. Using this device, it is possible to control the navigation in the 3D environment using your free hand. For example, you can go closer to the object, you can go back, you can turn right and turn left, you can stop your movement, you can restart your movement. We think that using this device is possible to have a much more immersive experience in the 3D environment, rather than using a mouse or a keyboard.
In the meanwhile, the researchers at the University of Florence, with the support of Albatros Marine Technologies and of the Welding Institute, are working on the development of MARTA, the vehicle housing sonar and cameras on board. Low thrusts would not allow the vehicle to overcome the currents. Nevertheless, an excessive consumption of energy would limit the duration of the mission. Some tests performed in pools enabled the researchers to find a good trade-off between thrust and energy consumption. One of MARTA's strong points is its innovative and intuitive graphical interface, through which archaeologists may easily configure a mission without the help of an expert programmer.
Here we are near to the coast and we would like to inspect an area, for instance this part, And through the graphical interface, we can select a path. And here we have many waypoints in the sea. We can change them. For instance, try to following the coast profile. Here on the left, we can try to select the desired depth and the payload we want to use. So during a mission, we can use optical payload or acoustic payload, an altimeter, and so on. And finally, we can decide if we want to navigate at a fixed depth or at a fixed altitude.
For the first sea trials, the team from the University of Florence moved to the CSSN in La Spezia, the Italian Navy's Center for Naval Support and Experimentation, which has provided an invaluable logistical support. The tests were carried out within the collaboration between the CSSN and the ISME, the Inter-University Center of Integrated Systems for the Marine Environment. After many months spent at the computers and in the lab, this is the moment of truth. And it's a beautiful moment. Marta behaves exactly as planned. She diligently and correctly follows all the received commands and dives to depth. Trapani, June 2015. After years of work, the vehicles are ready, though they have never met each other before. They do so for the first time in Italy, in Trapani, where, altogether, they will be tested. At first, the tests are performed in the waters of the Sicilian port for the final setup of the engines and of the navigation software. Then the boat carries the robots to the waters of the Egadian Islands, a genuine cemetery of wrecks from every era. Researchers from the Heriot-Watt University of Edinburgh test out their software specially designed for archaeological research on a commercial vehicle, the autonomous vehicle Iver 3.
Okay, the vehicle should travel approximately 20 meters on the surface.
They managed to locate the wreck of a cargo ship at a depth of more than 50 meters. To test the Typhoon and Marta, the wreck of Cala Manola is chosen, not far from Levanzo Island. The remains of a Roman ship that sank with its cargo of amphorae some 2,000 years ago lie at 25 meters depth. After a few tries, the sonar locates the wreck. The optical payload collects the images of the seabed. Once the vehicle is again on the support ship, a mere 10 or 20 minutes later, the entire archaeological site is reconstructed in 3D.
Nowadays, the computer technologies allow to obtain a rich map of the archaeological site in about 1 hour after the dive. So the archaeologists can easily study the situation and plan the day after operation.
In the clear waters of the Mediterranean, the underwater vehicles of the ARROS project have proven their ability to identify a wreck and study it with onboard sensors.
I'm very looking forward to use this technology in the Baltic because we have usually cold temperatures, rapidly changing weather and poor visibility, and this is exactly the conditions that those robots may help very well.
There won't be long to wait. The second stage of the final tests is scheduled for July in the cold waters of the Baltic Sea in Tallinn, Estonia. The first dives in an abandoned stone quarry of the Soviet period. For years, inmates condemned to hard labor dug down, carving out a small crater. On the shore of the lake that was formed after the shutdown of pumps that drained the water, the temporary laboratory of the ARROS project researchers has been set up. The UCAT is in its element. It moves without stirring up mud from the sea bottom, and its cameras explore the interiors of the submerged structures. Cooperation between vehicles also proves a great success. Commercial vehicles of Heriot-Watt University in Edinburgh acoustically identify several targets of interest and communicate the respective GPS points to MARTA, which dives into the water and quickly locates, thanks to its cameras, the 2 digging machines lying abandoned on the seabed. The time has come to test MARTA offshore. 2 hours of sailing, and the support boat has brought her to the wreck the Estonian archaeologists call the Mystery Ship. It is the wreck of a sailing ship, probably dating back to the 12th century, a ship about which virtually nothing is known.
And the wreck was found only a couple of months ago by an Estonian Navy mine hunter during the mine hunting mission. So this is basically one of the first times we are taking a closer look at this shipwreck.
MARTA is deployed into the water. On the surface, the engines and the navigation system are tested. Then the robot dives to capture images of the wreckage to help identify and date the wreck with certainty. But the story of the sailing ship is destined to remain a mystery for now. During the dive, MARTA loses some buoyancy necessary to maintain the vehicle neutral in water. The engines fail to bring the vehicle back to the surface, and it comes to rest on the seabed. Fortunately, the depth is only 25 meters, and a diver following the mission intervenes successfully, recovering the robot. It still proved a valuable experience for the designers, allowing them to pinpoint a problem which, had it arisen at greater depths, might likely cause the loss of the vehicle. The ARROS project has demonstrated that a heterogeneous fleet of robots is capable of exploring vast tracts of ocean floor in search of submerged archaeological sites without endangering the lives of divers, and that the technology has now evolved enough to seek out wrecks of the past at even greater depths.
The goal of the ARROS project was to develop and adapt technologies and tools for underwater archaeology. We think we have achieved this goal, but we also think that the same technologies can be useful also for other fields of underwater research, such as biology, geology, and environmental protection.
Scientists have used their spacecraft to photograph every square centimeter of the far side of the moon. But only now do they begin to approach the vast expanses submerged within the depths of the ocean. It will be thanks to the contribution of robots created by the ARROS project if, in the future, a complete map of the bottom of the sea is drawn. The last virtually unexplored environment on our planet.